Alrighty, partners, here we aims to talk about game theory, prisoner's dilemma, dominant strategy, Nash equilibrium. First, let's introduce the idea of a payoff matrix. So if you think about firms' strategic decisions about how much to produce, at what price to produce, and what effect that might have on their competitors, you might be wondering how in the heck you're going to format that. How are you going to set that choice up? Well, a payoff matrix is the normal way that we do this. So here's just an example where we'll come back to this, but the idea that there's two firms and they each have a choice about producing 30 million pounds or 40 million pounds. And depending on if they make 30 million pounds, the other side is going to have a certain reaction. Or if they produce 40 million pounds, the other side's going to have a certain reaction. And so you can trace how the profit's going to look and what the best strategy is going to be. We'll start our foray into game theory with a little something I like to call the prisoner's dilemma. So I'm not just the only one that calls it that. It's the name for it. It exists like this, and it's not limited to just economics. When each firm has an incentive to cheat, but both are worse off if they cheat, it's known as a prisoner's dilemma. So here's the way the game's setup goes. Each player has an incentive to make themselves better off, right? And that can be at the other player's expense. And so when both players act in the way that betters just themselves, and they are thinking they're doing it that's going to benefit them and hurt the other person, they actually end up both worse off than if they had cooperated. Let's look at some examples. All right, so we've got two players, Thelma and Louise. Louise will be our column player. Her payoffs are all in purple, or they're on the right. That's the form it's always set up, so that even if it's not colored, you can see sort of how it's going to go. And Thelma has two choices also, and her payoffs are in orange. So they're caught near the scene of a crime, and there's some circumstantial evidence, but not enough to sort of prove that they did this crime. So they're being held in adjacent cells, and they're being given the option of confessing or not confessing, right? So if they don't confess, let's look at Louise. If she does not confess, she gets either a 5-year sentence if Thelma also does not confess. So this top left box here is when they both don't confess, whereas the bottom right box is where if they both confess. Louise confesses, Thelma confesses. So top left box, they're both not confessing. They both get 5-year sentences. If Louise does not confess, but Thelma does confess, then we move down to the bottom left box, and Louise gets, you guessed it, a longer sentence because she should have confessed. Thelma confessed, threw Louise under the bus, and so Thelma gets a lighter sentence. Louise gets a 20-year sentence. And on the top right, if Louise does confess, throws Thelma under the bus, but Thelma does not confess, then Louise gets the minimal sentence and Thelma gets a 20-year sentence. That's harsh. What if they both confess? Thelma confesses, Louise confesses. We're looking at this bottom right box. They both get 15-year sentences. So if you're caught in this situation, you want to have a plan ahead of time, right? You want to make sure that you and your partner can trust each other to do the right thing. Now, what's the right thing in the world of criminality? The right thing here is to get the least possible jail sentence for both of you. And that's going to be up here. But here's the problem. The game usually doesn't end up with success for both of them, where they both keep their lips zipped. Usually, and it's designed to do this, usually one side or maybe both sides will confess, and then they both actually end up worse off. Okay, let's talk about that. So the prisoner's dilemma game that you just saw has a dominant strategy. What is a dominant strategy? It's the strategy that's in your best interest regardless of the action played by other players. So not all games have a dominant strategy, but the ones that you'll see in most introductory courses do. So what's the dominant strategy? The dominant strategy here is to confess. And why is the dominant strategy for both Thelma and Louise to confess? Let's run through the options. If Louise confesses, she doesn't know what Thelma's going to do, but basically we're looking at the confess column. If she confesses, she gets either a 2-year sentence or a 15-year sentence. Now, let's imagine what happens if she does not confess. She gets a 5 or a 20. Both are worse. More time in jail. And so Louise is drawn to the confession. If she does not know what Thelma's going to do, she's drawn to confess. Her dominant strategy, the one that gives her the least jail time regardless, is to confess. Thelma also faces the same trade-offs. If she confesses, she gets 2 years or 15 years, whereas if she does not confess, 5 or 20. So she's also drawn to confess. And we think that the normal way that this game will end, this is why it's called the prisoner's dilemma, is that they'll both end up confessing and being worse off. Where would they like to be? Up here. But unless they've got a rock solid trust and agreement in place, they probably won't. How does this relate to economics, you might ask? Well, I'm glad you asked. Because these can just as easily be dollars and firms trying to get the most profit. It's not limited to murder. So back to the definitions. We talked about dominant strategy. That game did have a dominant strategy. The Nash equilibrium is a different idea, and that is known as a non-cooperative equilibrium. It is a setup where you know what the other player has chosen. Now you need to know what is your best option, what's your best strategy. That's the Nash equilibrium. If you know what the other person is choosing, then you choose your best action. That's your Nash equilibrium. And you're not friends with them, so you don't already have an agreement whereby it's going to change their behavior, for instance, if you take a certain action. And to go a little bit further, if there's such a thing as a dominant strategy, what is a dominated strategy? And that is, just as you might imagine, the inverse. So a dominant strategy would be the optimal strategy, best regardless. Dominated then is if it's always the worst strategy, right? So you can ignore it. So if there is a dominant strategy, all other strategies are dominated. There can be a situation where there's not a dominant strategy, but still dominated strategies. But that gets a little more complex. If you have not seen A Beautiful Mind, a story of John Nash, you can see where he comes up with the idea of the Nash equilibrium here, and it's a bit crass, but he talks about how there's a bunch of friends at the bar, and they're competing for a prize, and the prize in this case is the very sexist going home with a pretty lady. So there's one that they all think is prettier than the rest. She would be, this is a little gross, but she would be the prize, right? So should they all compete against each other and not cooperate and collude with each other, hoping that each one will be the one to get the prize? John Nash says no. He says, what if instead of competing with each other for the prize and knocking each other out and only one person gets the prize, let's all decide not to go for the top. Let's decide that we're all going to go for a lesser prize, and we might actually all have a better outcome as a result. So anyway, it's a great movie, even if it's got some sort of very old-fashioned ideas of what a prize can be. All right, so here's an economic game. You got Warner Brothers and Disney trying to figure out whether or not to advertise. Warner Brothers is your row player. They advertise. They get either 250 or 550. If they don't advertise, depending on what Disney does, they get -80. That would be a loss. or a profit of 320. So is there, first question, a dominant strategy for Warner Brothers? What do you think? Yeah, I mean, it sort of suggests it already, but what is the dominant strategy? Dominant strategy will be, for Warner Brothers, they get a better payoff if they advertise than if they don't advertise. And Disney, well, they're in the same boat. This is a symmetric game where the payoffs are the same for each side. So Disney advertises, they get $250 or $550, depending on Warner Brothers. And if Disney does not advertise, negative 80 or 320, both worse off. So both Disney and Warner Brothers have a dominant strategy of advertising. And of course, most of us go, oh, but that's so sad. You could be getting more profit here. That requires that they have to collude. So if they don't know what each other is going to do, they're stuck in the dominant strategy, which is to advertise. Competitive firms, lower prices. It's in line with everything we've sort of been learning so far. Non-competitive firms, higher prices. All right, quick gut check. What's the definition here? The strategy that has a higher payoff than any other strategy, no matter what the other player does, is, it's not this one, because that requires that you know what the other person is doing. And while those may be true, the actual title for it is Dominant Strategy. Let's dominate! All right, so here's another game. To advertise or not advertise. Johnny Appleseed, they're our column player, so their payoffs are going to be on the right. They not advertise, 710 or 610. A little bit better than advertising, 700 or 600. So, maybe advertise? But apple growers, what's their dominant strategy? So they're on the bottom here. They get 500 or 440 if they advertise. But if they do not advertise, this game payoff is 550 or 580. It seems as if maybe not advertise is the better strategy here. All right, y'all. Two firms are the only producers in the market. Each firm is trying to decide whether to advertise. If firm B advertises, firm A earns $2,000 in profit without advertising and $1,800 if A does advertise. If B does not advertise, A earns $2,200 in profit without advertising and $2,000 if A does advertise. If A advertises, B earns $3,000 in profit without advertising and $2,700 if B does advertise. Starting to feel confused. If it does not advertise, if A does not advertise, B earns $2,600 without advertising and $2,400 if B does advertise. What's firm B's dominant strategy? What's your strategy? Make a little box, right? Make a payoff matrix. Here we go. All right, it takes a while to set up. But if we set it up this way, we can see pretty quickly that we're looking for B's dominant strategy. If they advertise, $2,700 or $2,400, which is a worse deal than if they do not advertise, $3,000 or $2,600. So, what's firm B gonna do? Not advertise, that's for sure. And it's always good to practice these more times than you think, because it's just a muscle that gets built. All right, so what's happening here? Nikita and Margaret are in a Cold War. Should they build a missile or not? So the payoffs here are not dollars, but they're in, I don't know, happiness or safety or whatever. You want positive. You don't want a negative payoff. Negative is bad things. So Nikita, this is Nikita Khrushchev, if he builds the missile, it's -10 or 8. Whereas if he doesn't build the missile, it's worse. Negative 20. Now I've upset the dogs. So -20 or 0. So we think he might be tempted to build the missile. Let's see what Margaret says. If she builds the missile, -10 or 8, which is better than -20 or 0. Don't build the missile. So this explains a lot of your arms races. Both sides will build the missile, and everyone's worse off. classic prisoner's dilemma. So there's lessons here for climate change and for, as well as other big international problems, and that is to get together, kind of like a cartel, get together a trade treaty or a climate treaty, or some of the things you've seen in the last few years are attempts to overcome the prisoner's dilemma by getting in place a robust trust situation and agreements that people are accountable towards, because nobody really wants to end up here where you're spending a lot of your taxpayer money on weapons of mass destruction. The dogs have spoken. The dogs of war. And once again, we revisit the arms race. It's a problem as old as time. Countries have to show that they are strong like ox. And so they spend tons of money signaling such, and everyone's worse off.